Today we came to the Muca neighborhood in Sao Paulo to see how the world is made. Shall we? Today we'll look at Editora Libraria's work, the first company in Brazil to make globes. It was founded in 1974 by an Italian named Mario Fiorentino, at a time when maps were drawn by hand.
I'm Mario Fiorentino, an Italian from Naples. When I arrived here in Brazil, I arrived in Santos, then we got here in 1961, on April 17, 1961. Well, it's been a long time, right? I started working at SEMP, and from there I solved some problems for the company. Then I left and started my own company, which was a business for repairing electronic devices. Then I opened Libraria, a publishing house, because I loved reading and books. During that time, I met a guy who wanted to develop a globe, but he couldn't do it. So I decided to take over, bought his project, and moved forward. We began by hiring cartographers, adding names one by one. This system called Setup lets you create the pool and add names and other details. Honestly, look, it took 2 years of work to finish to create a globe the way I really wanted, you know.
When I look at a perfectly spherical object like this, I keep wondering how we turn a flat drawing into a ball. Don't worry, because by the end of the video, you'll know. But to start with, it's cool to understand that they make 3 different types of globes. There's a plastic one with internal lighting, a cellulose paper one, and a miniature one that also works as a piggy bank. Let's start with the plastic one. The plastic globe begins with these 2 pre-printed polyvinyl chloride sheets. For flat earthers, your globe is complete already. The video could end here. And what's interesting to notice in this drawing is that it's completely distorted. Take a look at the map of Brazil. It's all squeezed to the side. It's really crazy how this turns into a decent drawing. Some globe models reveal information only when lit. In these, the plate is opaque and printed on both sides. When the light is off, you see only what's visible. Turn it on, and hidden layers appear inside the globe. Inside the globe goes this half sphere. This hemisphere made of high-impact polyvinyl chloride. The piece goes into a machine called a vacuum form, where the transparent polyvinyl chloride sheet is heated. When it gets really soft, the vacuum will stretch the piece, and it will mold itself over the polyvinyl chloride half sphere. And then, those drawings that were distorted will take on the correct shape. The excess is removed with a hammer and a punch, which is a pipe-shaped knife, and then with a utility knife, all done by hand. The half sphere gets a layer of glue along the equator, and a plastic ring that serves to join it with the other hemisphere. On the top and bottom, there are 2 caps that fit into the meridian ruler, which is screwed onto a base. Now answer me quick, why is the planet's axis mounted at an angle? Is it a manufacturing defect? Or is it so we can see the information better? It's because that's the natural tilt of planet Earth in relation to the sun. That means the planet actually spins at an angle, 23.5 degrees. In fact, it's because of this tilt that we have the seasons of the year. If things were different, the equator would be extremely hot with no variation. So what is this ruler measuring? It's called a meridian ruler because it's positioned just like a meridian, just like those lines that go from one pole to the other. It marks the tilt in relation to the equator. So we'll have a 0 right here at the equator when it's about halfway. Here, it's 45 degrees. So if someone is here, they're at the 45th parallel. At the Earth's axis, or the pole, you'll have exactly 90 degrees relative to the equator. Is ready. Just add the label, protective plastic, and box it. With the globo ready, we can see how cool this idea of having 2 different layers of information is. So, when the globo is turned off, we can see all the relief of the map. What is redder here are the highest parts of our planet, and what is green are the lowest parts. But when I turn it on, we can see the division between the countries. One challenge I hadn't considered in a globe factory is that they can't keep a large stock, since countries change names. Just so you have an idea, there's one of their globes here from the 80s, up here. The Union of Soviet Socialist Republics stopped existing in the early 90s. Burma is now called Myanmar. Yugoslavia split into several countries. West and East Germany unified into one country. Let's examine the cellulose globes. For the paper globe, it's different since it can't be molded like plastic. What will we have? First, this sheet was printed on thin, shiny paper and glued onto a thicker sheet. If you look really closely, you'll see there are some strips with no information at all, where it looks like the countries have been stretched out. This strip will be cut off on a table with a press that has several blades. Already in the right shape, it will come out as a kind of 12-pointed star. Next, this star will be placed on a base with a glue layer already applied. The two pieces go into a hot press where the glue melts and the paper molds over a half sphere. The graphic challenge here is to make the parts that were separated on this star-shaped paper come together perfectly. When we have the hemisphere, to connect the two parts, place the southern hemisphere in the mold, add a white glue-soaked ring, put the northern hemisphere on top, and hang the planet on a clothesline to dry. To complete the equator line, place a tape. Then, attach two plastic caps with time zones to the poles, along with a ruler and base. And what I think is coolest in the end is that even though it came from a completely flat object, from that paper star in the end, we can't notice any difference in height between the segments. Tiny globes are made in yet a third way. The plastic hemispheres arrive, but the printing is done using a method called pad printing. They're not manufacturing here today, but we have earlier footage, basically. It's a silicone stamp in the shape of a half sphere, which picks up the ink on one side and then places it on top of the hemisphere. It would be a pretty simple thing if it were done on a flat surface, but not once again. The design appears distorted and only takes its final shape on the globe. To make it harder, some globes still have 4 different colors. Each time you stamp here, align it with the previous print. The production capacity here is 400 of these large globes per day. And there are more than 30 different models. For example, there's a super educational one with big letters, so kids can read it easily. A historical map of 1500s, 1600s explorations, a continental map with each continent in a different color, and one showing endangered animals. And for those who like astronomy, like me, there's still the celestial globe, which is like a drawing of the layer of stars in our sky, and the lunar globe. So now, when you have the opportunity to be a space tourist, the moment you look at Earth from afar, like it's a little marble, you'll remember that a big part of what you learned about that little planet was thanks to one of the most fantastic educational objects of all, which is the terrestrial globe. And as you saw today, it starts from a completely flat sheet. And if you have any doubts about this whole story of being flat or spherical, we filmed in Espiritu Santo to show the Earth is round, as people have known for about 2,000 years.